Hi, so in this video we're going to be looking at the Edexcel or Pearson mathematics paper for June 2018. It's actually paper 2. Like I've done before in the previous playlists, I'm going to aim to work through this for about 20 to 30 minutes or so. We'll see how far we get. Please do have a go at each of the questions. Stop the video, have a go, and then compare your solutions. Okay, so let's move on then to question 1. They start fairly straightforward with these types of papers, so it shouldn't be so tricky. We've got simplify m to the power of 3 times m to the power of 4. Well, actually, we're going to add the indices together, so we're going to get an answer of n to the 7. Okay, and then we've got simplify 5np cubed, all in brackets, cubed. Okay, so just be a little bit careful about this, because what we mean by that is that each of the terms inside the bracket is going to be cubed. So the first thing that we're going to do is we're going to cube 5. So that's going to be 125, because 5 times 5 times 5 is 125. Okay, and then we've also got the n. So the n itself needs to be cubed, so that's going to be n cubed. And then finally we've got p to the 3 cubed. Well, that's exactly the same as saying p to the 3 times p to the 3 times p to the 3. So that's actually going to be p to the 9, and that would be the answer to this particular question. Please do note that it's actually 2 marks on this question, so very typically students might forget to multiply this out, so you would get 1 mark for that if you forget one of the terms. Okay, let's have a look at part C of this question, which is simplify. So I think the easiest way with this is just really to reduce it as you go along. So at the moment I've got 32 over 4. Well, 4 will divide into 32 8 times. So actually I can just get rid of that 4 and, if you like, make it 1, and get rid of that 32 and make it 8. Okay, and then we've got q to the 9 divided by q to the 3. Well, that would be q to the 6, because we subtract the indices, and then we've got r4, or r to the power of 4, divided by r to the power of 1. So that's again exactly the same as subtracting the indices. So what we end up with is 8, and the q term is going to be q to the 6, and then the r term would be r to the 3. Okay, and again, that's a 2 mark question, so it's worthwhile making sure that you check your answers with those. Okay, let's move on then to question number 2. And it says find the least common, or the lowest common multiple of 40 and 56. Well, there's a couple of different ways of doing this. You could write them all out if you wanted to. However, for me, I tend to find the highest common factor, and then I use that to be able to work out the lowest common multiple. And the way I'm going to do that is by using factor trees. So I'm going to start with 40. And I'm going to say that's the same as saying 2 times 20. And the reason I put a circle around the 2 is because it is a prime factor. Okay, same again with 20. I'm going to go 2 and 10. And then same again with 10. I've got 2 and 5. So what I do know is that 40 I can work out, or I can write as equal to 2 times 2 times 2 times 5. Okay, and let's just check that. So 2 times 2 is 4. 4 times 2 is 8, and 8 times 5 is 40, so that's absolutely correct. Let's do the same exercise with 56, and again I'm going to multiply or divide through by 2, and I get 2 times 28. Do exactly the same, 2 and 14, and then I've got 2 and 7, and again 2 times 2 times 7, 2 times 2 times 2 times 7 is going to be a value of 56, and all of these numbers are prime factors. Now what you'll notice is I've written them in such a way now that I can work out the highest common factor for both 40 and 56. So the HCF is going to be this factor multiplied by this factor multiplied by this factor. So the HCF is going to be 2 times 2 times 2, which equals 8. Now I do appreciate they've not asked you for that, they've asked you for the lowest common multiple. Well, the lowest common multiple is the highest common factor, which is 8 times what's left, 5 and 7, times 5 times 7, so that's going to be a value of 280, and that would be the answer to this question. And I'm very aware that there are other ways of working this out. That happens to be the way that I use. It's perfectly no problem at all if you decide to do it a different way, that's perfectly fine. However, when I look at the next question, I've actually been asked to work out the highest common factor of A and B. So I can actually use the same technique. What we're saying is that A is equal to 2 times 2 times 2 times 3 times 5, because this 2, 2 and 2 is the same as 2 cubed, and then times 3 times 5. And B, I'm going to write it out again, is 2 times 2, now this time times 3 times 5 times 5. Okay, and again I've just expanded those 2 squared and those 5 squared. And then really, as we did before, the highest common factor is the factors that are common. Okay, so 2, 2, and then this time I've got a 3 over there and I've got a 5 over there. Okay, so if I want to work out the highest common factor of A and B, I'm simply going to do 2 times 2 times 3 times 5, and if I work all of that out, it's going to give me 60, and that would be the answer to this question. So I've used the same technique in question A, or part A, and also part B. It doesn't really matter in the scheme of things, but it's just something that I've got a lot of confidence in doing. Okay, so let's move on then to question number 3. Okay. And this one, we've got the line L is shown on the diagram. I'm going to find the equation. Well, with all straight line graphs, you've got what they call the general form. And the general form is y equals mx plus c. So basically, we've got 2 things we need to find out. The first thing we need to find out is this value of m, which is called the gradient. Okay. I appreciate that they've used the letter m, but it is the gradient. So the way we work out the gradient is the difference in y divided by the difference in x. Okay, so that we'll have a look at in a minute or two. The other bit that we need to work out is the value of c, which is the y-intercept. So it's actually where it crosses the y-axis. Well, that's fairly straightforward because we can look at the graph and see that it's -6. Okay, so we know that one is going to be -6. Let's have a look back at the gradients. Well, probably the easiest way to do this is to draw a little triangle in here. Okay, and it allows us then to just work out the difference in y divided by the difference in x. So the difference in y is going to be the number of jumps between this point and this point, which is 6, divided by the number of jumps between this point and this point, which is 2. So that's going to be 6 over 2, so the gradient is equal to 3. So we've now got the components that we can use to actually answer this question. So to write out the equation itself, we can say that y equals 3x, so that's the value of the gradient, minus 6. And that would be the answer to this particular question. Okay, so let's move on. We're about halfway through the video and we're going to move on now to question number 4. Okay, please do stop the video, have a go at some of these questions for yourself. Okay, so we've got Raya buys a van for that plus VAT and she pays a deposit. Well, okay, I'm always a little bit suspicious when I see these sorts of questions because I think you need to take them in bite-sized pieces. Let's just have a look at the first line. Raya buys a van for 8,500 plus VAT at 20%. So what are they telling us? Well, they're telling us that we need to work out the total value of the van. So what I would do is in my calculator, I would say that the van cost is equal to 8,500 plus 20%. Now you might work it out slightly different to me. I might say that's actually the same as saying 8500 times 1.2. But either way, hopefully you'll get an answer of 10,200 as the total value of the van. Okay, and then it says she pays a deposit, he or she pays a deposit for the van. She then pays the rest of the costs in 12 equal payments of £531.25 each month. So let's find out how much the 12 equal payments are going to be. So again, if I put this into a calculator, I'm going to get 12 times 531.25, and that means that actually she's paid £6,875 in instalments. But it also means if we take that away from the 10,200, it means that if I put these little dots in, it means therefore the deposit will be the difference, which is the difference between that and that. So it's going to be a deposit of £3,825. Okay, so we've now got the components in place to be able to answer the question, which is to find the ratio of the deposit to the 12 payments. Okay, so the numbers themselves look a little bit scary, but with the calculator you should be able to work out that if we're looking at the deposit, okay, to the payments, we've actually got a ratio of 3825 to 6875. Now if you pop that into a calculator, you should be able to reduce through, and again, you might do it slightly differently to me. I might just reduce through by 5 and see where we are, but eventually you should get to 3 to 5, and that's the answer to this particular question. Okay, I hope that's all right for you. Let's move on then to question number 5, which is where we're being asked to draw a graph. Okay, so we've been given some values on a table, and we're asked to firstly complete those values. So all we're doing really is taking this, which is going to be a quadratic equation. In other words, it's going to, or rather it is a quadratic equation, it's going to look like that, okay? The reason it's going to look like that is because of this x squared term. So this x squared term has the ability, or has the effect to make this into a nice smooth curve. Okay, so let's have a look at popping some of these numbers in. So the first thing I'm going to do is I'm going to put, let's say, -2 into the equation. Okay, so when the value of x is -2, I'm going to get -2 squared minus -2 minus 6. Okay, so just be very, very careful with how these things are plugged in. Okay, so this is when x equals, if I put -2 up there for you. Okay, so -2 squared, well, -2 squared is the same as saying -2 times -2, which is a positive, and it's going to be a positive 4. Okay, and then I've got -2. Well, two minuses together mean a positive. So I've got +2, and then I've got -6 at the end. So actually 4 plus 2 is 6. 6 minus 6 is going to be 0. Okay, so this would be a value of y of 0. So let's do exactly the same now with -1. So the minus numbers are always the most difficult numbers. I tend to do them, to be honest, at the end, but I think for the purposes of this video sometimes it's a little bit easier to do them right at the very beginning, and then we can focus on those negative numbers. Okay, so let's have a look at -1. So when x is -1, okay, I'm going to say -1 squared minus -1 minus 6. Okay, so again we've got -1 squared is the same as saying +1. Minus -1 is +1 again, and then -6. I got 1 plus 1 is 2, minus 6 is going to be -4. Okay, So hopefully the negative values you've been able to work out. The positive values should be hopefully a little bit more straightforward. Let's have a look at when the value of x is 1. So again, I'm going to say 1 squared minus 1 minus 6. Okay, so I know I've put that in brackets. I just wanted to illustrate that this number should really actually be left in brackets until you remove them. So I've got 1 squared is 1 minus 1 minus 6. So 1 minus 1 is 0, minus 6 minus 6. So when x is 1, y is going to be minus 6. Don't be concerned if you get this situation, because with this situation it just means that we've got this curve that we talked about a little bit earlier on. Okay, finally let's have a look at when x is 2, and again we're getting into our stride a little bit now. Okay, so 2 squared is 4, 4 minus 2 minus 6. Well, 4 minus 2 is 2, and 2, positive 2 minus 6 is going to be minus 4. So that would be a value of minus 4. And then again, when x is 3, I've got 3 squared minus 3 minus 6. If you like, put those in brackets again. So 3 squared is going to be 9. 9 minus 3 minus 6. Well, 9 minus 3 is going to be 6, and then 6 minus 6 is going to be 0. So we've actually got 0 for this. And then really it's just a case of plotting this onto a graph, and bearing in mind that I'm looking to achieve some sort of curve. I'm not quite sure whether it's going to be the same as that or similar to that, but nevertheless I'm looking for a nice smooth curve. Okay, so if I plot this, I'm going to have my value of minus 3 minus 6, which is going to be minus 3 plus 6, which is up here somewhere. Okay, that's the first one. Minus 2, 0. Minus 1 minus 4. 0 minus 6. 1 minus 6, okay, 2 minus 4, and then 3, 0. Now hopefully you can see that actually when I join all of this together, I'm going to try to do it without moving the paper too much. Hopefully you'll see that when I join all of this together, I'm going to get a nice smooth curve, more or less, that looks like that. Okay, so just as a point here, you'll notice that this point here is slightly above the bottom, the turning point of the curve, and that's absolutely right. You need to make sure that you've got a nice smooth curve at the bottom of your quadratic graph. Okay, hopefully you'll be able to see this okay. If I just pull that up a little bit, a nice smooth curve towards the bottom here is quite important. Okay, so if we go to part C, I won't actually go to the actual question, but it says use your graph to find estimates of the solutions to the equation x squared minus x minus 6 equals minus 2. So in other words, what we're looking at is the y value is minus 2. So basically, if we put a line across here, it's actually where the quadratic crosses those lines. So now if I actually write in those two values of x, so I'm looking at this value of x here, which is going to be about 2.7, I think I got on my original, and this one is minus 1.5. So I'll just pop those into there for you, and that would be part B of this, or part C rather, of this particular question, where we've got a value of x equals minus 1.5 and a value of x to be 2.7. Don't worry too much if you're not absolutely the same as this particular numbers. There is plenty of leeway with these types of questions, and they do give you a margin to work in. Okay, we might as well, it's 19 minutes into the video, so we might as well finish off the last question, which will take us through to the end of question number 6. Okay, so it says a force of 70 newtons acts on an area of 20 centimetres squared, and they're very helpfully given us the pressure equals force over area formula. Okay, So let's just have a look at that, and again, like we did before, take this as a, in bite-sized pieces, really. So if we look at the first bit, let's find out then the pressure that's acting on that particular area. So pressure, this is, if you like, scenario 1. Okay, this is 1. So scenario 1 is pressure equals force over area. Okay, and if we plug in the numbers, I've got pressure equals 70 over 20. So the pressure is going to be 7 over 2, which is equal to 3.5. Now, it's newtons per centimetre squared. Okay, because we're working on centimetres squared and newtons. Okay, so that's pressure 1, if you like. And then it says the force is increased by 10 newtons, the area is increased by 10 centimetres. And Helen says the pressure decreases by less than 20%. Well, let's work that out. So let's look now at scenario 2. Okay, so this is going to be 2. Okay, so we're going to use the same idea. We're just going to use the same formula. Pressure equals force over area, but this time we're going to use slightly different numbers. So it says the force is increased by 10 newtons, so now it's going to be 80, and the area is increased by 10 centimeters, so it's actually going to be 30. Okay, and if I plug that into a calculator, I'm going to get 8 over 3 as just reduce it. Okay, and that is equivalent to 2.6 recurring newtons per centimetres squared. Okay, so make sure you've got the same units for these types of things. Okay, now it's better in these to stick to the actual fractions, because what we're asking to be done, or what they're asking, is that Helen says the pressure decreases by less than 20%, and is she correct? Well, let's have a look at the percentage decrease. So the percentage decrease, and this is a formula you need to remember, is going to be the difference over the original. So percentage increase or percentage decrease is the same formula, difference divided by original. So using the calculator, okay, I'm going to plug this in straight in, that I've got a difference now between 8 over 3 minus 7 over 2. So actually you can work that out either separately, or you can plug that into the calculator, and it's going to be quite an interesting calculation for the calculator, but it's going to be that. Okay, so that's the difference bit of it, and then the original is going to be 7 over 2. So there's quite a lot of numbers going on there, and then you might choose to do them separately if you want to. That's perfectly fine. What you should get is going to be, the top is going to be 5 over 6 and the bottom will be 7 over 2. Okay, now that's going to give you the fractional fractional decrease. So to work that out as a percentage, I need to multiply that by 100, and what I'll get at the end of it is going to be 23.8%. Okay, so in this particular case, Helen is incorrect. Okay, so we can write Helen is incorrect. Okay, so I'm very aware that, again, people will have slightly different methods and slightly different ways of doing this. That's perfectly fine. You might choose to stick with the 0.6 recurring, and again, that's absolutely fine if you do that, providing you use difference over original, multiply by 100 to get your percentage decrease. You're absolutely fine. I tend to prefer fractions myself, but that's just the way that I was taught in my early years. Okay, I hope that's okay for you. We're at 24 minutes or so into the video. Please do have a look at all of the questions, and I hope that you found some benefit in doing them. Please do add a comment, subscribe to the channel. I'm going to be starting video 2, which is going to be carrying on from question 7 onwards, and I'll look forward to seeing you inside the next video.